Okay, so I'm going to go through. This problem is actually really strange because the loop is within another loop. So first off, you got to figure out what you're going to call your loops. And this is really easy. So we have our I1, I2 is this one we first encounter, and then I3 would be this one. So when you go around the circles to build these things, keep in mind that this one, I1, is going to be this resistor, this one, and this one. I2 would be this one, and this one, and I3 is just these two. So that's going to be where the first mistake is going to be made. But let me show you what you end up with. I'm not going to show every process. But the first one, if you look how we went, I went to this guy, then I have 6. Remember, it's I1 minus I2. That's the inner one on the top, okay? And then we have the next one, which is 4, I1, I3, and then 5 by itself. And the whole thing should equal 9 volts. The second one, keep in mind, it's just this loop. So starting off with, remember, you have to get I2 minus I1 because we're talking just the inner one. So I2 minus I1, this would be I2 minus I3 for 8. And this is just I2 by itself. That's why you get this thing listed like this. You'll see these whole arrows when you look at the final one, but I'm breaking it apart so it's easier to understand what I did. The last one's the very, very inner circle. It's only 2 resistors. So 4 is going to be I1 and I3. So it's I3 minus I1. And 8 is going to be I3 minus I2. And that's why you get this equals 0. Next step is you basically distribute and put like terms together. And for the practice of explaining my thing, I'm going to call these equation 1, equation 2, equation 3. Makes it easier for when I show you what parts we put together, right? So the first thing I would do is try to get rid of one of the internal variables. Since they all 3 have all variables, you got to try to cross something out, right? And so using substitution method, I grab equation 2 and equation 3, okay? And what I do is I divide because I like the numbers being smaller. So I took this guy and divided it by 4. That's why I said equation 2 divided by 4. Or 1/4 times that. So I get 1.5 I1 plus 6 I2 minus 2 I3 equals 0. So that way I can cross out the 6's, right? You have a minus 6 here, this is plus 6. And we just add the rest and bring it down. I end up with 14. Remember, this is negative, right? So we go 15.5 I1 minus 1.5 I1. I get 14 I1. This disappears, and we just get negative 6 I3 equals 9. That calls new equation 5, right? So then I got to look back at my original 3 and make my next step, okay? Next step is I want to somehow get rid of one of the variables between these two guys. Since I did 1 and 3, right? This was, 2 and 3. Next one's going to pick the top 2, equation 1, equation 2. Easy way to do that is if I look at this, I can just either multiply this guy by 3 or divide this one by 3, all right? So in this case, I decided to go ahead and multiply the top one by 3. So then I can just add them. This would be 24, and this is negative 20. Everybody see what's going on here? This is easy. So 3 times this is negative 24. I can cross them out. Now see, this is actually moved all the way down. I didn't want to put it on one big sheet. It makes it hard to explain. But so then what you end up with is, if you bring everything down, is negative 18 I1 plus 28 I3 equals 0. And the next thing to do is just move things, right? So move the 18 to the other side and then divide. You end up with 1.55 I3 is equal to I, okay? That's a simple calculation. Now we're going to move down to this, okay? Now, one of my newly formed situations, okay? Look at this guy up here. 14I minus 6I3 equals 9. I'm going to sub it in, add new equation 5 with this. I1 equals 1.55 I3, right? So I take that one and I add it into this equation. So it's 14 instead of I1, I have 1.55 I3, right? Minus 6 I3 equals 9. When you work this whole thing, add it together, distribute it, all that other fun stuff, you end up with I3 equals 0.573. Now you can feed it back into that equation you just used, 1.55 times 0.573. You find out I1 equals 0.888, okay? So I've solved for I1, I've solved for I3, okay? And then the next step is what? Take the original starting equation, that's what I did, and put those values in. So look at this, I got it on both on one screen, right? I1's here, So I put it in for I1. I3 is here. I put that in for I3. We're solving. We're going to get numbers, right? Negative 3.553, and this is 6.876. This is a negative value, right? So when you get done, you're going to end up with moving it to the other side and dividing. You end up with I2 being 0.415. Now, this was the big thing. I just cut this all up to make it easy. But if I go to my RAV table, I'm going to move this over to see what's going on here. I put all my resistors up here. And for every time it says I1 minus I2 or I3 minus I2, always remember, always subtract the smaller I from the larger one when doing these things. So if they're sharing a current, I1 and I2, right? For example, look, I'm sorry, move this back over here. Like 6, it's with I1 and I2. If whichever one's bigger, you're going to subtract the smaller one from it to get your answers. And therefore, you can determine all the different volts that are going through it. This would be the current, right? That's a resistor. This would be our volts. And this is just amps times volts. Will give you your answer. Well, this is a nice quick explanation of how to do this whole thing. This is it all. This is the key. But sometimes it's hard to follow with all the arrows, but it's everything kind of showing how it was done. But I just broke it up to make it easier. All right, cool. Hope you understood it.